Welcome back to Kamal Kunj Home Academy Encounter with Physics. In this session, we will discuss about the derivation of inverse square law using Kepler's third law. Derivation of inverse square law using Kepler's third law. Newton used Kepler's third law for calculating the gravitational force between Sun and the planet. Now let small v be the orbital velocity of the planet and small r be the radius of orbits assuming that orbits are circular. Let us assume that orbits are circular and r is the radius of the orbit and small v is the orbital velocity of the planet. Then force of attraction is given by force is proportional to v square upon r, that is acceleration towards center. Force is proportional to v square upon r. This question be now orbital velocity is v is equal to 2 pi r from t. 2 pi r is the length of the orbit and t is the orbital time period. So velocity is equal to orbital velocity is 2 pi r upon t. Now this implies that v square is equal to 4 pi square r square upon t square. This is equal to 4 pi square r cube upon t square into 1 upon r. Now, according to Kepler's third law, Kepler's third law, we have r cube upon t square equal to constant. It means this quantity is constant. Hence, v square is proportional to 1 upon r. Since r cube upon t square is constant and this is also constant, so this quantity is constant. Therefore, v square will be proportional to 1 upon r. Let this is second equation. Now, from equation 1 and 2, from equation 1 and 2, we get force is proportional to 1 upon r square. That is, gravitational force is, force of attraction is proportional to square inverse of the square of the radius of the orbit. Thus, you see that the force of attraction is proportional to square of the radius of the orbit. It is inversely proportional to radius of the orbit. Now, we will stop here and continue further in the next session. Till then, goodbye and thanks for watching.